All right, everyone. My name is Igor Edelman, and I welcome you to CloudSlam 09. You have joined a session with Nati Shalom, the CTO and co-founder of GigaSpaces.
Yeah, hi there, Igor. Thank you for the introduction. Today what I'm going to talk to you is basically share with you some of the experience that we had with developing and deploying application on the cloud. I'm going to do that in the way I'm going to do that is basically go through GigaSpaces just as a quick introduction, and then go through a summary of the challenges that people face today when they're trying to deploy an enterprise application on the cloud. And later on, what I'll try to do is kind of provide sort of a practical guideline on how, based on our experience, is the best way to deal with that. And obviously, we'll end up with some open session for questions, and hopefully that will be an interactive session. So I'll start with the quick introduction to GigaSpaces. So the important thing, I think, and I don't want to spend too much time on that, is that we've been dealing with distributed computing for a long time. For us, cloud computing came in a perfect timing, and it's basically an enabler for building and delivering a lot of the experience that we had with years of dealing with very high-end application in the financial world in a much simpler way, because cloud really brought the ability to run cluster machine and distributed computing machines or an environment in a cost-effective way, in a way that everyone can experience with, whether he has a big IT organization or a small IT organization. So that's kind of the, you could see here some of the list of customers that are using us. You could see that a lot of them are kind of very distinguished names. But the important thing is that we've been around, we've dealt with all the issues, so the issues of distributed computing and the things that cloud computing brings to the world is a very natural fit for us. Before I start, I wanted to kind of touch, I know that a lot of the discussion would be around what is cloud, and I really don't want to talk about that specifically. I do think that we do need to touch base with what brings us to deal with cloud, because I think that with all the discussion on cloud, we kind of miss the point from time to time. If I look at that from a business perspective, it's very simple. We have issues of capacity planning, which is very complex. Today, most of the organization is built or is provisioned by the peak load. We take the peak load, and obviously we take and provision the machines based on that number. When obviously the average is much lower than that. So if we have, for example, a peak that requires 10 machines and an average that requires 3 machines, we'll have basically a very low utilization, and 7 machines will be pretty much redundant most of the time. If we'll also take into account that it's not just a production environment that is going to be affected by that peak load number, it's also the staging environment, as well as the disaster recovery side, we basically end up with 21 machines just standing there for a one-time event. So obviously the Cont methodology for dealing with these type of things is
Nati, I'm sorry to interrupt you. Are you sharing your desktop, because none of the attendees can see slides?
Oh, really?
Yeah.
Okay.
If you can do that.
So I did.
Ah, here we go.
Okay. Do you see the slides now?
Yes. Yeah.
Okay.
Perfect now.
Cool. So if we look at one of the first recent research that measured that type of arguments, I think that it's clear that capacity planning is too complex, and therefore moving to clouds would be a very clear motivation. Another thing which is very important is the time to market. Obviously, trying to deploy an application on the current IT environment takes a lot of manual work and a lot of effort that obviously impact the bottom line, which is time to market. And in many ways, we are in a point where not all the applications are going to be successful at the end of the day, but yet we're obliged to basically make a lot of investment beforehand before we even know that the application itself is going to succeed and be deployed and generate the traffic that we expect it to be. So the ability to know that in the best way is not to make any investment beforehand and run the application in a quick and dirty way, and only when we see that it's successful, make the right commitment. And all that really sums up into cost-saving initiative or value. That's kind of I think the main thing that brings organization to look into cloud computing in the first place. If we look again at the ideal world from that same Forrester event, it's very clear where we want to be. We have on the bottom line, we have resources, and we have commodity hardware infrastructure in this case, and at the top we have our application. And between that we have a classic resource and demand scenario where application would require resources, and we need to supply the demand for those resources in one way or the other, and pay for what we use. That's pretty much, I think, sums up where we want to be. The trouble is that if we look at existing application and the way they're architected, they're pretty much built in silos. We have specific products for the database tier. We have specific application for the business tier, for the messaging tier, and for the web tier. Each one of them assumes different things about itself and about the way it handles high availability, the way it handles the performance, the way it handles the management, and we need to somehow glue them together. All that, I think, work reasonably okay in a static environment where we control all those moving parts. But try to imagine what will happen if we try to take that same environment and same application and move it to something more elastic like the cloud. Try to imagine what will happen if we'll add another machine, for example. Most likely nothing will happen unless we do something, which is really not the elastic world that we want to be in. And even if in that case, even if we'll add a machine and something will happen because we built the application to actually accommodate that new resource, the chances are that we wouldn't be able to even predict how the application is going to behave. How much throughput are we going to gain out of that by adding another machine? If our application is not linearly scalable, the only way we can know it is by adding those machines and measuring it, and only then we'll know if it works as we expect or not, if it works at all. So in many cases, being even flexible in the way the application is being configured and deployed is not enough. They also need to be built in a way that will be linearly scalable so that we'll be able to predict beforehand how it's going to behave when we add in more resources. I did some sort of a summary of a discussion on the cloud mailing list where I tried to kind of aggregate some of the challenges that people posted on one of the recent threads. And I came up with this list, which is obviously not surprising. I think most of you should be familiar with those items. These are the challenges that people face when they want to deploy an application on the cloud. So it's pretty straightforward. Adding additional resources dynamically, we already talked about that. Most applications are not geared to deal with that. If we have, if we look at Amazon, and even with the recent announcement of Google App Engine, trying to deploy a J2E application on the cloud is not a first-class citizen to be, to say the least. Persistency is a very big issue. You're either bounded to use one of the persistency services that are provided within the cloud, but still the way you need to interact with it is very different than the way you built the application so far and the way most of the existing applications were built. And it would work only on the cloud. The other thing that I think is important is that we will always be as strong as our weakest link, as the saying say. With cloud and distributed computing, that saying has more meaning. It basically means that the fact that we can add more machines and we can be elastic on that, and now a lot of the problems of automating a lot of those things already there, doesn't mean that our application is going to be scalable. Because what will happen if we'll add more machines and our application wouldn't be able to deal with it, or we have a centralized database that all our servers point to, we're not going to be able to scale because of that. Memory resources is becoming more available, and obviously in a cloud-based environment, leveraging the memory resources that we have today can be very economic and obviously lead to better performance. Memory also tends to be more elastic. It's easier to move data from memory resources than file system. So we do need to think on how we utilize memory resources within our architecture, and obviously we need services that will enable us to deal with that. And so far, again, most of the application were not geared to build around that. Provisioning and management tools is also important. We can't really assume that that's been taken care of by our IT, and we have management tools to support that. Pricing and licensing is also an interesting challenge. How do you run an application that requires a license that comes from a sales guy that you signed a contract with? That also leads to an interesting challenges on how you can be elastic in this type of world. So that's kind of I think the main challenges that we're seeing. I also picked up an interesting summary from, again, one of the recent blogs that talks about how they solve it today, what people are doing to deal with those challenges. And as you could see from this, and I gave here the actual reference to that, so you could all see that. The interesting thing is that you could see that one solution is really to look at all those challenges and solve it yourself. And you could do that. There are tools, there are frameworks out there. There are basically framework almost for everything. And you could start and glue that and deal with that separately. You could add multiple web servers, multiple load balancer, glue them together, and do all these sort of things. The question is whether that's your business and that's what you want to invest in. And knowing that it's not going to end up by one-time investment, it's probably going to require some continuous effort on your end. So most users wouldn't want to do or to go through that experience themselves. They would want something more out of the box. So I tried to map here from an architecture perspective what are the tools and the architecture pattern that we could use to address each of those challenges. And again, I'll be very generic here because of time, but also because each one of them, may require a lot of discussion just on each of the points. But in general, we can deal with the dynamic resources using virtualization, not just on the operating system side, which is what most cloud provide today, but also on the middleware side, meaning messaging, data, application, and basically fill in the gap around that. We also need to deal with the lack of persistency by using some sort of an in-memory front end to our database and leveraging the fact that we have memory at the front end. The other thing that we can do is, on that same line, is think about the whole stack, which basically means that instead of trying to take all these type of moving parts and glue them together, we'll need to come up with something that covers all the moving parts in one stack and provides one coherent clustering high availability model across the entire web tier, messaging tier, data tier, and we wouldn't need to think about all those details on each of the tiers. We should use also memory grids, obviously, to solve some of those challenges. I can go through some of the other items here. I think that the most important one is also the out-of-the-box infrastructure for J2E, and obviously I believe that the infrastructure in the cloud should support J2E as a first-class citizen. That's pretty obvious. From a pricing and licensing model, I think that the Amazon pricing, Amazon Elastic pricing, would eventually become the model in which pricing is being dealt within the cloud, and most enterprise products and users would basically align to that. So that's kind of the way I think it will go through. The analogy that I use for the pricing model is if you think about rental car, that would be a very good example. You could rent something for a day that will cost you, a certain cost. You could lease it for a year or even more, and that would cost you a little bit less. Or you could buy it, which obviously will cost you the least. The same thing we could do with our IT resources. If we don't know how much we're going to use them, we can pay per use. If we have slight idea of how we're going to use that, we can use some sort of a reserved instance model, which is in enterprise world called subscription, or buy and purchase a product perpetual. So the end result that we expect once we apply all those patterns is we'll come up with something in the line of the current picture that you can see here, the current diagram. What you can see here is a web front end, which in our case would be stateless and only used as a router to route requests from the end users on the left-hand side to the actual application on the right-hand side. On the right-hand side, we'll build all the business logic, and we'll package them around a middleware that will include both the messaging and the data, and will be partitioned across the entire application stack. In that case, we can virtualize the entire application stack and be very elastic. The web tier look at all the business logic tier as if it was one big server, and obviously the end user look at the entire application as one big server, which ends up with a virtualization of the entire application stack. So in doing that, we're actually virtualizing not just the operating system, we're virtualizing the data, the messaging, and the entire application. And because we can virtualize the entire application, we can be very elastic, add resources, remove resources without breaking the actual application. Another interesting thing is the database and the way we handle that. Instead of directly interacting with the database, which is a really a complex thing in a dynamic environment, we're going to push the database behind and use in-memory as a front end and keep the database in sync. So whenever we boot the system, it will read all the data from the database and boots its state, in-memory state, from the database. And when it goes down, it will, or before it goes down, it will continuously update the database with the updates on the in-memory, so the database will remain the persistent archive of our application so that we wouldn't lose state if the application goes down for whatever reason. Now, before we move to the actual practical steps on how we apply all those patterns, because so far I talked about the patterns in general, the thing that I wanted to kind of emphasize is that even though we can do all, we can get to that end goal that I mentioned, even today, I wouldn't recommend going to that in one go. The first thing that we need to find out is how we can break or start building towards that model in steps. And I'll talk about the actual steps in a second, in the next slide. The other thing that we need to be clear of is that linear scalability needs to be built into our application and architecture. We don't have to deal with that in the first day, but we need to have a clear roadmap to get there. Because without linear scalability, we need to be aware that we're not going to be at the point where we're going to have predictable behavior in our application. So we need to strive towards linear scalability and need to have a clear roadmap to how we get to that point. By minimizing vendor locking, which is one of the main concerns, we need to be able to basically abstract the application. To be clear, we'll always have some level of locking in our application. We cannot avoid it, but we can manage it and minimize it. And the kind of tips that I'm pointing here is basically tips that will allow us to reduce fairly significantly the lock-in that we may have if we're not going to use them. So obviously, abstraction would be the main pattern. We can enable portability by enabling the application to be decoupled from the actual cloud provider services. We can enable it to host different type of web container. In the Java world, that would be Jetty, Tomcat, Glassfish, or whatever. We can design it such that we can interoperate with different languages. So choosing different languages and mixing different languages would be something that wouldn't require a total re-architecture of our application. We can also minimize the API lock-in. So obviously, whenever there are standards, by all means use them. But standards are covering only a small part of our application code in most cases, so we need to be aware of that. And the next thing that we can do to basically avoid lock-in when standard doesn't exist is use abstraction. Spring, I think, is a very good example on how you could apply POJO-based experiences and dependency injection to do a fairly effective abstraction on our code. The last thing is that you don't have to, if you're dealing with a new project and you're thinking about cloud, but you're not sure that that's where you want to end up, you can basically just future-proof your application, meaning that you're going to be ready for the cloud, but not necessarily deploy the application on the cloud, and think about how you do that for every new application that you're launching in your organization. And obviously, avoid long-term commitment, and that would be by the use of pay-per-use model and things of that kind. That kind of summarizes the steps that I wanted to kind of highlight. The steps that I tried to highlight is driven by, it's basically a roadmap to the end goal that I mentioned earlier. So the axis that I use here is the effort versus the value, and I try to kind of provide a roadmap of steps on how we could get from one point to another, assuming that we have a tier-based application that is static, that is not yet ready for the cloud. What we can do to take that application, the same one that I showed in the first slide, and move it to a more dynamic environment. How we could get value from the first effort, second effort, etc. Obviously, dealing with the web tier as the first steps would be the easiest win for us. Because of that, we could move from static provisioning to on-demand provisioning, deal with self-healing, things on that line. Keep the database as is, statically synchronized, and even a performance bottleneck and a scalability bottleneck, but at least we can get rid of the static provisioning that we had at the beginning. And by doing that, we could be elastic to a degree. Obviously not elastic infinitely, but elastic to a degree. In many cases, compared to where we are today, that in itself is a big win because we can save a lot of the static provisioning overhead. And I gave you some examples for this cost saving that we can get out of that. The second thing is trying to virtualize our business logic, which is, again, doesn't require a lot of changes to our existing code. It just basically means that we could use some a different implementation to get to that point. That should be easy as well. As you can see, everything that involves data is going to be more complex. It's going to generate more value, but it's going to be more complex. Because in most cases, if our data model is based on a centralized data model, then most likely we're not going to be able to just put it on the cloud. We'll have to redesign our data model to work with a distributed model. That regardless of the actual product that we're going to use. Any data that we need to provision on a distributed environment would need to go through that step. That's kind of the, and I try to kind of provide some measures on how we could do and how we could save some of the costs associated with that. Let's go through the steps. I'll start with the self-healing and dynamic scaling and see how we can do that using a J2E application that is currently deployed on the web, and how we could increase the dynamic scalability of that application without changing the actual code, without touching the application. We're assuming that the application itself is based on, there is a load balancer, there is web tier in front of that, and there is a database at the back end. We'll deal with dynamic scaling just by increasing or removing web containers and informing the load balancer that those new containers are available and let the load balancer know about it dynamically without breaking the application. Self-healing will be something that we'll do by detecting when there is a failure in our application and provisioning a new instance of our application on an alternate machine and connecting that new alternate machine back to our cluster so that the load balancer would know about it and would be able to deal or route requests to it, again, without having the user experiencing any of that. So let's see how we add self-healing and dynamic scaling. If we look at the picture here, basically what you could see of the picture is this classic architecture of load balancer, the web containers. Note that we've wrapped the web container with something that we call processing unit, which is basically a container of containers. The container of containers will enable us to add the elasticity to the web containers and add SLA-driven language for deploying application on these web containers. So that's kind of the first wrapper that we add into the application. And by doing that, we can get some sort of elasticity already. We'll see in a second how that works. The auto scaling itself would work by monitoring the CPU utilization, the number of requests per second on our web servers. We can also add other metrics to our web servers, custom metrics, for example, backlog, or other type of utilization metrics, and monitor the actual request. We would see exactly how that can be done also by giving some sample of code. If we'll have all those built in, meaning that we have the container of containers, wrapping our web containers, and talking to the load balancer, we'll have the monitors built into the web containers, so each web container will report its status, its number of requests, etc. We can start and apply SLA policies, dynamic SLA policies. Dynamic SLA will basically be a mapping of our business requirements into the actual application itself. And we'll see how that works by giving a sample code in a second. So for example, we want to make sure that our application always serve our web clients with no more than 100 second latency, or giving a number of throughput. When we cross a certain number of requests per second, we'll know that we're breaching an SLA and we need another machine to share the load. Let's see how we can basically do that. That's a snippet of a code that implements that SLA using the GigaSpaces new administrative API. So what you could see is that through the API, we can actually access all the web containers by accessing the container of container, which is referred to as processing units, and then getting from those web containers the actual number of requests per second and measuring the actual total requests per second in our system. If we see that the number of requests per second breaches, meaning that it crosses a certain threshold, we can do something about it, again using that API. We can actually call and instantiate another web container. And in this case, we'll also call, in the Amazon environment, we'll also call an increased instance, which basically means that a new web container will be added to our system. So the way it will work is that, let's assume that we have those three containers, web containers. We monitor those web containers, and now we detect that there is a threshold breach. Let's assume request per second is beyond a certain threshold. What will happen is that we monitor that, we go to that breach, we instantiate in another container. That container dynamically joins the cluster, and also there is another agent that talks to the load balancer and adds that new web container to the load balancer list. And now the load balancer recognizes that there is a new web container and will share the load between all those containers, and that's how we get the auto-scaling implemented to our application. Now, the important thing is that we didn't have to change if our application was built in J2E and we had it packaged with a WAR file, we could get all that without changing the code, without changing our application, and without even dealing with images and without dealing with all the configuration that is normally required when you're accessing a cloud computing environment, and without dealing with all the challenges that I mentioned earlier. Obviously, you wouldn't see here, but in most cases, we'll also have a database connected to here. In this specific case, we didn't deal with the database. The database still there remains a centralized point of synchronization. We just dealt with the web tier. Now let's see how that magic can happen and how we can simplify the complexity of doing that on the cloud. How we can take a basic WAR and deploy it on X amount of machines and have all that automated through our application. There are basically three elements. The first element is installing our application on the cloud. We'll have an application repository, which is basically an S3 repository. So the first thing that we do is we copy the files that comprise our application into S3. That's the first step. The second step that we'll do is we'll wrap the application with some sort of an XML. I'll show you an example in a second. And that XML will be the application deployment descriptor. The application deployment descriptor will basically tell us how many instances we want to run and what is the SLA that needs to be kept for that application, the number of requests per second, et cetera, et cetera. We'll also be able to tell not just how many instances we want to deploy, but how many instances we want to start when there is a breach, and there is a lot of other elements such as security, persistency configuration, et cetera, that is part of that. But essentially, that would be our application descriptor. We'll use a multi-tenant application provisioning tool that will basically front-end, in our case, EC2. And we'll use that to manage our application. Those who have experience with EC2 know that EC2 works on a user level. User level basically exposes you all the all the instances that you're running, but it doesn't show you which of the instances is the load balancer, which of the instances is the web container, which application is actually running. So that additional management tool adds that application-aware manageability and enable us to manage the lifecycle of an application. A user also in this case, and that's why it's called multi-tenant, is not necessarily an Amazon user. An Amazon user could be broken down into 100 users on this type of tool, and we can run those different users in a multi-tenant environment without one interfering with one another. So basically what I'll do is I'll take that XML, click on a button here to deploy that XML, and then click on a button here that is called deploy. When I'll click on deploy, interesting magic will happen. What will happen is that that management tool will talk to the cloud provider, which could be EC2 or GoGrid or even your private cloud, and interact with it to instantiate the machine based on the profile that I already described in the actual deployment descriptor. As soon as the application starts, it also assigns to certain machines a certain role. We'll have a machine that will be assigned with the role of a load balancer. We'll have machines that are assigned with the role of a database. We'll have a machine that will be assigned with the role of a web container. The role basically enables us to decide what's going to be the bootstrapping policy for that specific machine. And when that machine starts, it will basically take the application from the application repository and grab it to the actual machine. By doing that, we can actually have the entire application up and running without interacting with any machine directly. We could do that and run multiple applications in the same way. Again, because those different applications would run on different machines, they would be multi-tenant and totally isolated from one another. The management tool will enable us to view each of the applications separately and manage the lifecycle of those applications separately. We also added in the configuration the ability to inject data grid and database functionality as part of the deployment. So basically, the deployment can define the entire stack, the load balancer configuration, the web application container configuration, the business logic configuration, the data grid, and the database configuration. All that can be provisioned in one click. You don't need to install anything. You don't need to download anything to do that. Here is a very simple example of how a simple configuration would look like. You could see that the only thing that I added here is basically the WAR file of my application. I didn't need to change any code of that. And I'm pointing to a certain version of my application. The interesting thing is that pointing to different versions would be as simple as just changing the code here. So if I want to upgrade my application or use another version of application, I don't need to create a new image. All I need is just put it accessible in the S3 container and launch the application and grab it from that point, and that's it. Obviously, there is more details into that, such as security setting, roles, and all those type of things that will be part of that descriptor, but that configuration will be deployed in the environment itself. So to wrap up and start the open discussion, and I've seen that there are some questions here already, I wanted to kind of point who is actually using it and how they use it, what are the actual use cases. The most interesting one is a telco organization that built a SIM provisioning application and didn't want to host that application on the cloud because they figure out that that application is facing a lot of fluctuating load whenever they launch a new campaign. But other than those campaigns, it's fairly stable in a relatively low number of machines. So obviously, using cloud on that end made a lot of sense for them. They had an issue there with dealing with security, for example. How do you interact? I see that there are questions here. I'll answer those questions as soon as I finish that slide, so don't worry about that. the challenge that they had is that this application also was referencing backend system in the organization, ERP system and other services. So how can you take that type of application and deploy it in the cloud? What they did is a very interesting model. They basically deployed the front end, the web containers, on the cloud, and use a secure channel to their backend services that runs on-premise. For that, basically, I would refer as a hybrid cloud. They were able to be elastic on the front end. They were able to use our cloud tools to automate all the deployments, all the monitoring, and still connect to the backend systems and save a lot of cost as a result of that. Another telco company built a software as a service application. Their challenge was taking an application that was not built for software as a service, and they wanted to leverage the software as a service as a model by taking that voice over IP application, a call center application in this specific case, and host it somewhere else. So again, just to make it clear, previous to that, a customer had to install that in their local data center, connect it to their PBX and their switch, and use it. That was the only way you could use it. What they wanted to be in is that you will be able to just connect to a service and use that service to manage the call center and make that service connected to its PBX and without installing the actual call center application on their IT premises. What they have is several challenges that is relevant to anyone who is looking for taking an application and trying to move it from a standalone application to a software as a service model. Obviously, the first one would be scalability, managing customers or number of concurrent users of one organization versus managing concurrent users of all the customers is going to lead to a lot of concurrent users, and obviously the application needs to be re-architected. Another thing is the lifecycle management and obviously the performance and reliability that I mentioned earlier as the challenges. So rather than developing all that themselves, they chose GigaSpaces and basically built the application. They were able to run on 150 machines and get fairly low latency. Low latency is something that is not that easy to achieve in the cloud because all the communication was based on an in-memory messaging and didn't really go through any file system operation in a critical path of the application. Another global media company was able to basically run the pilot model that I mentioned earlier. They had a new application, a new game that they wanted to launch. They were not sure that that's going to be a successful application. They didn't want to invest and buy a lot of hardware and resources to manage that application. They wanted a quick way to deploy it publicly, experience with it, see if it's successful, and only then decide whether they want to deploy it on their private cloud or not. Obviously, they were able to use this simple deployment that I showed earlier to save a lot of the time and get the existing application up and running in a production-ready environment with full availability and scalability built into the application itself. There are other two examples. I'm not going to go through all of them. The interesting one is the financial services startup. In financial services, you would have two types of customers. One of them is very high-end, where they would want to install everything in the local premises because of latency and other things, and relatively low-end customers that wouldn't mind to pay the cost of latency, but would mind paying a lot of money for that. So that application that customer were able to build a fairly rich client on the cloud and provide relatively good latency, few milliseconds, 300 milliseconds. I mean, in cloud terms, that's still reasonable. And we're able to use it both for the high-end customers and the low-end customers. For the high-end customers, they use it mostly as a demo in a POC environment. They didn't use it for production environment, but they were able to use it to reduce a lot of the sales cycle that they previously had. Previously to that, the sales cycle looked like they had to take the application, install it in the local data center, and only after that long operation, they were able to experience the application and see if it fits their requirements or not. With the cloud, they can actually deploy the application on the cloud data center and have the customer access it and play with it as if it was running in its local data center, and therefore reduce the sales cycle. The low-end customer were able to actually use it in production. And obviously, again, time to market was fairly low. So that's kind of the type of customers using it today. So I think that the takeaway that I wanted to highlight here are pretty obvious. Even though there are many challenges to the cloud, as there would be with any new technology, with the right tools, those challenges can be breached even today. Customers, even to my surprise, are using it into production, and we're able to move very swiftly by taking, for example, J2E application and deploy it in the cloud and leverage the elasticity and a lot of the values that I mentioned earlier by taking off-the-shelf products rather than trying to develop them themselves. You could develop it yourself. Again, at that point, you'd need to deal with the investment that you'll have to do for yourself. It's not impossible, and it's actually doable, and some people have done it. My best, I would say, suggestion would be to choose a simple application first. Simple application would be those that don't have strict security requirements, those that don't have a lot of moving parts and a lot of dependency on backend system, and would therefore have a much clearer path to a return on investment. You don't want to fail on your first project on the cloud. And if you look at the data center and your IT organization, what's very interesting to see from a lot of discussion is that not all the application organization are mission critical. Not all of them needs to run on a very high SLA data center and machines. But if you really look at the data center, you would see that the data center was not geared to provide those variant SLAs in many cases. So we can actually take those at least non-important, non-critical application as a pilot, if you like, as a first experience, deploy it on the cloud. We can also use the cloud for testing. That's a very easy thing to do, provided that you build your code in a way that will be abstracted from the actual cloud infrastructure itself, which means that you'll be able to port the application from the cloud to back to your production environment in a very simple way. And with that, I think I'll add the frontal part of the application of the presentation, and I'll move to the discussion in a second. Okay, let's see what our questions do I have. How do you maintain, the first question from Ricky, hi Ricky, is how do you maintain transaction integrity between memory grid and the database, two-phase commit, etc. The answer to that is we use redo log, reliable redo log, which basically means that we log all the transactions in memory, and when we actually commit, the commit ends in memory. So the user is not really blocked on the database when there is a commit. Once the commit happens, we also keep a copy of that log in a redundant memory. So there is another copy of that log in another memory, and then we try to basically go through a retry operation into the database. If it was successful, then obviously everything works. If the database failed, then the redo log keeps that transaction in place, and as soon as the database comes back alive, we'll retry the operation back to the database. In this case, we can keep the database up to date, but avoid synchronizing or blocking the end user into the operation to the database itself. So that's kind of the easy part of the answer. The other question on that regard is what will happen if the memory fails. Then, as I said earlier, there is a copy of that log, which means that there is a hot backup waiting. And if the front-end memory fails, then the back-end memory takes over and remembers the exact point where we failed and continues to send those operations back to the database, so we're not going to lose any data, even in a case of failure. The other question from Ricky, a lot of questions from Ricky actually, what happens to your updates to the data if instances fails before it's committed to the database? I think I answered that. Am I locked to the GigaSpaces API when accessing the memory grid? I would say that partially. If you're using standard APIs like session store and things of that line, then the answer would be no. If you are trying to use the in-memory data grid today, the API that we expose is proprietary because there is no standard data grid API. We are working these days on a JPA abstraction, which basically means that within the next release, hopefully, you wouldn't need to go through that proprietary API. The other thing that is important is that we do integrate with existing database, so the fact that you will be using the data grid API doesn't mean that you need to change your existing database. So basically what we'll do is we'll take your existing data model from your database, load it into memory, and provide access to that data through our API. The data model in the database remains the same. The model in the memory is different. Right now, it will require access through a proprietary API. You could narrow down that footprint by using DAO abstraction, data access abstraction, and we support the Spring DAO abstraction, which basically means that a lot of the transaction semantics and transaction operation can be done declaratively outside of the code, so we can minimize, and exception handling, so we can minimize that change as well. And as I mentioned earlier, you don't have to start with it. So deploying the web application and getting dynamic scaling, self-healing, session high availability, and all that can be done without touching the code. Today, only when we're hitting the database and we want to use IMDG, that's the only part that would require changes to your code. Would you say that the IMDG is a system of record? Absolutely. And the database is becoming backup. I think I touched that. Let's see. Do we need to learn Groovy code in order to control the dynamic scaling? The answer is no. First of all, the code is available in Java, and obviously Groovy is used as a scripting language on top of our Java API. We will be providing a REST API as well, so you could use any language that you want to use on top of that. Even Java itself exposes different dynamic languages like Ruby and others, so obviously that is supported as well. But we do provide the programmatic access to all the administration API. We will be providing also built-in SLA script, if you would like, or policies. So for the simple case like the one that I mentioned today, you wouldn't really need to go through that exercise. The reason why I wanted to emphasize that is basically to show you that unlike many of the black box approaches, we believe that people want to have control over their system and want to be able to tune their SLA in their own, and not necessarily use only the black box solution that is provided, and obviously can lead to a fairly complex lock-in. Francis is asking, how do you monitor the persistence and avoid database to be overloaded? Basically, if we front-end the database with the IMDG, then basically all the update to the database is batched. If we see that the backlog on the redo log, meaning that we're not able to keep the update to the database at the pace in which the updates are happening in memory, then we monitor that and throw basically a memory shortage exception and slow down the updates essentially by slowing down the consumers that are updating the system to the point where the system would self-balance itself. Obviously, if there is a crash or a failure, then in that case we'll have to deal with that and we'll report an exception after a period of time that we haven't been able to recover it ourselves. What is the data access model? Get and put. The access model is available in various ways. Get and put is a good starting point, which is basically a map API. The main model that we use is a GigaSpaces as the core API, which basically maps to write, read, take, and notify. And we added an SQL query-like model, which is supported with that. So you could add a where clause which says, give me every object that is of type X that has this ID equals to, let's say, 1, and from today till a year ago. So all those type of things can be expressed in SQL. We call it SQL query. Okay, we're getting close to the last question. This is the time to actually post other questions if you have any. What about research in cloud computing development? What could be a really hot research point in that area? What cloud application developers really need? So I'm not sure what that question really means. I think that if you look at a lot of the research that is happening, obviously there are certain areas like the database and building an efficient data distribution model in the cloud is something that a lot of people are looking at. Another thing that you would see that a lot of research is dealing with is obviously security, and I think that's kind of the main area. There are a lot of other areas that I've seen, but I think I'm not necessarily the best person to ask about those specific research points at this point of time. For us, one of the things that we're dealing with is really how to abstract the data layer and make it non-intrusive. That's and still have the application run on a distributed environment and distributed data model. So that's an area that we're very much focusing on. Any other question? Okay.
Adi, this is Igor. Could you post just for everyone contact information if there are questions that are not asked yet, but somebody thinks, oh gosh, I wish I would have asked, how they could contact you and or your company?
Sure, I will. I will do that in a second. I also provided some references for those who are looking for the early access, and those that want the experience with the cloud. I did want to mention that we do provide that obviously publicly under gigaspaces.com/mycloud. You could log in there, get a free access to Amazon, play with it, run your demo, run either one of the demos or deploy your own demo. And there is a full description there on what you could do with that. Unfortunately, today I didn't have time to go through a lot of that experience, but there are webinars available and other things that will show you how you could experience that yourself. And I'll provide my direct email in case you have any further questions and references. So you can contact me directly. Here's my email. Hope you all can see that. And please feel free to send me emails or questions or anything else that you want to do.
And if you can share your desktop one more time, because right now we're just seeing the info screen, not your email.
Sure. Okay. I did put the actual email on the chat.
Oh, okay. I'm sorry.
Okay. So again, I'd like to point to the mycloud site. It is already available. I already, by the way, deployed application here, so you could basically see one of the applications that is being deployed. There is a built-in monitoring system that is integrated with that type of environment. You can see also this is one of the example applications, which is an e-commerce application that is already being deployed in that type of environment. Deploying an application, a demo application, is as easy as clicking a button, one of the buttons here. And basically, the screen at the low end shows you the actual machine and enables you to monitor the application and switch between the different instances of the different demos or applications that you want to deploy. You can see, for example, that specific application is actually also running on a secure channel that already have integration with the security of Amazon. You could also easily find the logs and monitor what's going on behind the scenes. So it was really built to enable you to do a lot of the meet a lot of the challenges I mentioned earlier, where it's the delivery, the deployment, the management, the SLA on the cloud in a fairly easy way, and you can see exactly what's running at any point of time. And obviously, as I said, all that is accessible through a free user that you can get through the login site. So you can either use the MyCloud SDG, which is our beta version that is upcoming in the next few weeks, or just MyCloud, which is the production environment and experience with that. And obviously, if you do have any other questions, feel free to contact me and send me an email. Okay, so thank you very much. Igor, do you have any other questions? Okay, thank you very much, guys.